Now that we've reminded ourselves of how composites come about, we're going to look at how to take the derivative of a composite function. And in order to do this, we use something called the chain rule. And so we might have the composite function f at g. And in order to take the derivative of f at g, well, first we're going to take the derivative of the f function, so f at g of x. Okay, so that's the first part. And then we're going to multiply it by the derivative of the g of x. So inwards, the derivative of a composite function is the product of the derivative of the outer function. So in this case, that's f of x multiplied by the inner function, derivative of the inner function. In this case, that's g of x. And in this case, we're actually going to use our alternate notation a little bit more frequently. So if y is a function of u and u is a function of x, and so this would mean that y is a composite function of x, then in order to get the derivative of y in relation to x, we actually can do two things. We can have the derivative of y in relation to u multiplied by the derivative of u in relation to x. And we're going to actually use this quite a bit, so keep this guy handy. Okay, let's try an example. We're going to start slowly. We're going to first identify the two composite functions that make up h of x, which is a composite function. So the first thing I see here is that this is the inner function. So I'm going to write that out like this. And then I can also see that f of x is the outer function here. Okay, now that I've identified both of those, I can go ahead and take the derivative using the same rules as I always have. Okay, now if I'm going to put this all together, so f of g at x is 3 over 2. Now instead of x, I'm writing g of x in its original form. Okay, multiplied by 3x squared. Okay, oops. Now I can put this together, neaten it up a little bit, simplify it. So I've got 9x squared. Let's go with the square root notation in this case, all over 2. Okay, let's try another one. Okay, so if y is 2 times u to the 3 power of 3 minus 5u plus 1, and u is x plus 3, we want to find dy dx. So we know that dy dx is dy du times du dx. So the first thing that I'm going to do is find the derivative of u in relation to y. So the derivative of y is 6u2 minus 5. And now I'm going to find the derivative of u in relation to x, and that's just going to be 1. Actually, let's use this notation here too. dy to du, derivative of u in relation to y. Okay, so now I can put these two things together. The derivative of y in relation to x is this guy, 6u squared minus 5, multiplied by the derivative of u in relation to x. So once I simplify that out, this is my final answer. And I might want to insert the function of u into this spot here. Okay, so instead of u, because I want to have the derivative of y in relation to x, now I need to put what u is. And this is what u is. So this is going in the spot of u. And maybe I would work this out. X squared plus, or x plus 3 all squared is x squared plus 6x plus 9 minus 5. And multiplying the 6, 54 minus 5 is 49. Let's try one more and then hopefully we'll see the new rule. Okay, outer function must be x to the power of 4. Derivative of that is 4x to the power of 3. Inner function is x squared minus 5x. Derivative of that function is 2x minus 5. Putting it together, oops, sorry, it's f of x this time, capital F of x. Okay, so I have 4. Instead of the x, I'm going to write what x is, to the power 3, multiplied by the derivative of g of x. Okay, so this, we should start to see that there is a pattern here. So we take the derivative of the composite function and then take the derivative of the inner function. Okay, so this is power of a function rule. So let's try one of those, just going straight to that. All right, so I'm going to take the derivative of this whole function first. So I'm going to have 5 exponent. The inside of this function stays as it is. This is technically g of x, and I'm going to reduce the exponent by 1. Now I'm going to take the derivative of the inside, and these are all just separate functions, so, or components, so I can just take the derivative of each piece. Okay, and now I can maybe simplify this. I've got some like terms here. So I want to bring that 6 out, and I'm going to go 5 times 6 is 30. I'm also going to bring the x out. Typically, we write things in order of decreasing exponent value. And so that one's done. Okay, let's try another one. So in this case, you might want to, and I do, I'm going to take this and rewrite it as x squared minus 3 to the power of negative 2. So that when I take the derivative, I'm not working with a quotient rule because I have no numerator anyways. So I just took the derivative of the first bit, negative 2 take away 1 is negative 3. Now I'm going to take the derivative of the interior function, just 2x. And now I'm going to rewrite all of it. So 5 times negative 2 times 2 is negative 20, all over x squared minus 3 cubed. Okay, and so we can get into some really, really difficult examples here. So let's try a couple more challenging ones. Okay. So I have the product rule here. So here's one function, here's another function. So I have to do the product rule. So product rule says take the derivative of the first one. So I'm taking the derivative of the first function. And now I have to apply the chain rule as well because the first function is a composite function. There's the first function. Keep the second function the same. This is added to. Keep the first function the same, even though it's a composite function. Take the derivative of the second function. The second function is a composite function, so I have to take the derivative of the inside of the function as well. Okay, now I'm going to have a look and see that I have forgotten to put a 2 here. So we're going to see that there's always these common factors that keep coming up again and again. And once we do a few of these, you'll see what I mean. So in the first term, I see that I have an x squared plus 3 times. And then I also have an x squared plus 3 4 times in the second term. So a common factor would be x squared plus 3. Remember, you always take the lesser amount. So x squared plus 3 to the power of 3. I also have 4x minus 5 to the power of 3, 4x minus 5 to the power of 2. So I can take that out as well, power of 2. And I also have some plain numbers. So I've got this 4 and a 4. So I can bring that out front as well. That leaves me with 2x and a single 4x minus 5 plus a single, and a 3, and a single x squared plus 3. And this will always kind of sort out like this. So this is a pattern that you should be able to look for. Okay, now I'm just going to leave all my factors out front here as is. And I'm going to clean this up in the inside. So 2x times 4x, 8x squared minus 10x plus 3x squared plus 9. All the factors out front stay as they are. And then these can be combined a little bit more. 11x squared minus 10x plus 9. Okay, let's try one more. And then there's quite a lot of homework, so you can give those a try as well. Okay, so the derivative of s. So first I'm going to bring down the exponent, write, it's t this time. Now I have to take the derivative of the inner function, which now I have to use the quotient rule. Okay, quotient rule says take the derivative of the first, which in this case is just 3, multiply it by the derivative on the bottom, t plus 1. Subtract, keep the first the same, multiply it by the derivative on the bottom, which now is just going to be 1, all divided by t plus 1 squared. I'm just going to rewrite this. It'll seem more clear why in a second. So I'm just going to give that exponent to the top and the bottom. And I'm going to clean up the top. I have 3t plus 3 minus 3t plus 2 all over t plus 1 power of 2. Okay. Okay, so now I can write this all as one expression. So I have 5, 3t minus 2 to the power of 4. If I just take a look here, I've got 3t minus 3t plus 3 plus 2. So that just turns into 5. All over, these denominators multiplied together is t plus 1 to the power of 6. And I can actually simplify it a little bit more because I've got 2 whole numbers here now, 2 regular numbers, 2 integers. And there's my final answer. Okay, so like I said, there's a ton of homework. Please make sure you do all of it. They are quite challenging. Make sure you set aside enough time to get it all done.